Okay. All right, so 25 said tan y over cosecant y equals secant y minus cos y. And before you guys left, I said that you have to work on, this was the second strategy yesterday when we took notes, you had to work on the right side of the equation that had two terms. So depending on what intimidates you more, this had like two trig functions, this had two trig functions, but this is considered to be one term because there's no plus or minus sign. This is considered to be two terms because there's a minus in between, and two terms is always going to be the side you work with if you have one term versus two terms, because it is easier to take two terms and combine them together to be one term than it is to take one term and invent new information to split them apart and make them two terms. Okay, that's typically an easier process. So if I'm working with the right side, what could I do with the right side? Take the secant, turn it into 1 over cos. And at this point, I'm going to think of the cos as being a fraction. I'm going to put it over 1 because it's like a whole number. And that next step was exactly right. You've got two fractions. You need a common denominator. So this one has a denominator of cos. This one has a denominator of 1, so it doesn't contribute anything. And so how would we get a common denominator? We're going to multiply by cos y over cos y. Okay, so the first fraction is going to stay 1 over cos. And what is the second fraction? Cos squared over cos. Cos squared over cos. Okay, so at this point we have a common denominator, that's cos, and what is on the top? 1 minus cos squared. Okay, so at this point we might be starting to look at the left side and kind of thinking of it as like this is our answer key and we're starting to cheat a little bit. So I don't know if you guys are starting to think this way, but when I see cosecant, I automatically think sine. Is anyone else starting to think that way? Okay. When I see tangent, I think sine over cos. So somehow we're going to want to get a sine. Somehow we want a sine to happen on the right side. Okay, 1 minus cos squared is sine squared. That's on our blue sheet. That's one of the Pythagorean identities. So right here, 1 minus cos squared is sine squared. So we can make that substitution now from the blue sheet. So I'm going to take the top of the fraction. I'm going to rewrite this as sine squared y over cos y, okay? And so this is the point where I'm really looking at my answer saying, how can I manipulate this to become what I know the answer should be? So how am I going to get a tan out of this? Not quite, because we don't have a plus and a minus over here, do we? What is sine squared? sine, right? It's sine times sine. So we could split the signs apart and write them as multiplication, right? Like expanded multiplication. So I'm going to do sine times sine, because that's the only way that I can kind of make the top bigger. I can't put plus signs, but I can put a multiplication sign there. So do you see a tangent in the problem now? Yeah, sine over cosine. So here's our tangent right there. Do you see a cosecant in the problem? Are you sure? You can make it though, can't you? So we see a sine. What do we do with the sine to make a cosecant? We're going to take the sine out and we're going to rewrite it as 1 over cosecant. Does that make sense? Okay, so this right here is going to become a tangent. And then this sine we're going to take out and we're going to rewrite it as 1 over cosecant. Does that make sense? Okay, so I'm going to say take the tangent, and then here's my multiplication sign, and then the sine I'm going to take out and I'm going to rewrite it as 1 over cosecant. Because it says multiplication, right? So anytime you've got multiplication, you could think of this part right here as sine y over cos y times sine, oops. Not keep, change, flip, because that's division. That's a fraction divided by another fraction. But the way that multiplication works of fractions is you just have the top fraction multiplied by the bottom fractions of the fractions, and so you can split fractions with multiplication really easily. So if you had two fractions multiplied together, you would just multiply the tops and multiply the bottoms, which means that if you're undoing fraction multiplication, it's really easy to just split things apart. So if I wanted to separate the two signs, I can do that. I can separate them into two fractions. If I want the cos to only go with this sign, I can do that. I just need this sign to have another denominator. I'll just put a 1 underneath it. And that's because multiplication of fractions is really nice. It's really easy to work with. It's the division that's a little bit tricky and the addition and subtraction that's tricky, but multiplication is pretty simple. Yeah. So I just basically split these apart. Think of the first one as tangent. Think of the second one as 1 over cosecant. And so the second one we're saying that sine is 1 over cosecant is what we're doing with the second one. So once I've got this, once I say the first one is tangent, the second one is 1 over cosecant, now I can just multiply straight across, and I can say I've got tangent on the top and cosecant on the bottom. So I think the hardest part of this problem was knowing that this is how algebra works. With algebra, you can split that multiplication really easily. Number 26 uses really similar strategies. So let's start it, and then I'll see if you guys can finish it. So if we have cos on the top, cos v over secant v sine v, that equals cosecant v minus sine v. So again, we're going to work on the right side because the right side has two terms. So what should I do first on the right side? So cosecant is going to be rewritten as 1 over sine. And then what do I do? Put the sine over 1. Multiply by sine over sine, get that common denominator. I'm going to go ahead and shortcut this a little bit. So my common denominator is sine. So what do I have on top? 1 minus sine squared. Okay, 1 minus sine squared. Okay, 1 minus sine squared is cos squared. Okay, and we have our goal is cos on top, secant on bottom, sine on bottom. We're going to separate the coses. So cos on top, secant on bottom, sine on bottom. Do you guys see how similar it is to the last problem? So what do we need to do to this? We don't have to change much, do we? What do we have to do? So take one of the coses.
Good morning, Rockets. Please, if you were supposed to take the ASVAB this morning, please report to the media center. Again, any Rockets that are supposed to take the ASVAB this morning, please report to the media center.
So we're going to take one of the coses and do what with it? And put a 1 over it and turn it into a secant. So I'm going to take this, I'm going to take it out, and I'm going to make it a 1 over secant. So we've got cos on the top, the other cos became a 1 over secant, and then the sine stayed on the bottom. Does that make sense how we were able to do that? Take the cos out, turn it into a 1 over secant. Okay. And then on the other side, that's just exactly the same thing. All right. Make sure your name is on those and then go ahead and get them turned in. So 21 through 26 should be done. Get your name on it, get it turned in.